Hi there, welcome to another video for higher level junior cert maths. We're continuing coordinate geometry. Now we're going to look at lines with the equation of the form y equals mx plus c. If we examine our page from the log tables, we'll see that we have our slope formula, length, midpoint, equation of the line, and up until now we've been using the first equation of the line. And we use the first one in purple when we know the slope of the line and we know one point on the line and we want to create the equation of the line. We're now going to look at the second equation of the line, y equals mx plus c. And this is particularly useful when we have the graph of a line. We'll remember that m stands for slope, and now we're going to introduce c. C in the equation of a line, which is the constant value, that stands for the y-intercept, which is where does the line cross the y-axis. We'll be looking at that in a lot of detail in some of the examples. First of all, for y equals mx plus c, in order to read the slope correctly and the y-intercept correctly, the equation must be equal to 1y. So if you have 2y, you will first need to divide everything in the equation by 2. If you had 10y, you would need to divide everything by 10 in order to correctly identify the slope and the y-intercept. Let's have an example of how we need to do that. So find the slope of the line minus 2y equals minus 8x plus 20. We need to divide everything by minus 2 in order to get 1y. So everything got divided by minus 2. And we were left with y equals 4x minus 10. If we compare that equation to y equals mx plus c, the general equation, we'll see that 4 matches up with m and minus 10 matches up with c. So the slope has a value of 4 and the y-intercept has a value of minus 10. And if we look at the equation of that line, we'll see that the slope can be calculated by rise over run. So I'm going to say I'm going to come from this point to this point. I'm going to come out 1 and up 4. So the rise over run is 4 over 1, which is 4. So the slope does work out to be 4. And the y-intercept, the point where it crosses the y-axis, is indeed minus 10. A second example. L is the line 2x minus 3y plus 6 equals 0, and K is the line 3x plus 2y minus 4 equals 0. Show that L is perpendicular to K. Well, what I did was I found the slope of the first line using m equals minus a over b, as we had come across previously, which gave me minus 2 over minus 3, so a slope of 2 over 3. And for my second equation of the line, I decided I'd use the form y equals mx plus c. So I rearranged it and brought the x's to the right hand side and the constant to the right hand side of the equals, giving me the equation 2y equals minus 3x plus 4. I don't want 2y. In order to be able to read off the slope and y-intercept, I need 1y. So I divided everything by 2, which left me with y equals minus 3 over 2x plus y. Compare that with the equation y equals mx plus c. I'll see that m has a value of minus 3 over 2 and c has a value of 2. So the slope of my second line is minus 3 over 2. In order to show that L is perpendicular to K, I need to multiply the two slopes together. If they are perpendicular, my result will be negative 1, which it is. So then I have proved that they are perpendicular. Just finding the slopes on their own isn't enough. You need to multiply them together to prove it. And finally, let's match some lines to their equations. So at the bottom here, I have 4 equations: y equals x, y equals x minus 2, y equals x plus 3, and y equals 2x plus 4. To match these equations to the four colored lines here, the first place to start will be to look at the y-intercepts. That's the biggest giveaway. And we'll remember that the y-intercept is the constant value at the end of the equation here. Y equals mx plus c. C is the constant, it's the y-intercept. So this line crosses the y-axis at plus 4. And if we look at our different lines, we can see that the orange line here crosses it at plus 4. So this equation is going to be for F, the orange line. In our next line, we see that it has a constant of 3, which means this line is going to cross the y-axis at positive 3, which is this line here, D. So we can say that this line equals D. Our next line crosses it at negative 2. So comparing with the graphs, we'll see that that is the green line, so which has a name E. And then finally, our first one doesn't have any number at the end. It's just y equals x. So that means it crosses the y-axis at 0. And examining the graph, we can see that this line G crosses at 0. So a dead giveaway, if there was more than one line that crossed at the same point, then you will start examining the slopes. And the slopes are the numbers in front of the x. So this line, first line, has a slope of 2. This second line has a slope of 1, a slope of 1, and a slope of 1. So begin by examining the y-intercept and then move to slope. That's lines with the equation y equals mx plus c. I hope you found that useful.